Olympic Fan 2 here. Now this is actually going to be a tutorial about hybridization states in organic molecules, and I got confused with this a little bit in my organic chemistry exam, and let me show you what I got asked. Now, what would you think is the hybridization state of oxygen in phenol? Now it looks like an sp3 hybridization here, doesn't it? But what if I tell you that if you have to choose between sp2 and sp3, the correct answer is actually tends to be more to sp2. Now why is that? Well, we can draw Lewis structures for this molecule, which look like this. So what happens is that the oxygen actually donates its electron pair to the carbon atom here in the aromatic ring, and what we are left with is a double bond and an oxygen with a single electron pair and a positive charge. And what happens now is that we get a negative charge in the para position, and in the next Lewis structure we can draw it for the meta position. And I'm not going to draw the third structure here because it's the same as this one, but you get the idea. So if we would average the states of phenol, we would probably tend to be with a more likely reality that tends to go for these structures here. And this is why this molecule, if you have to choose between sp2 and sp3, you have to choose that the oxygen is sp2 hybridized. Now we can also look at another example here. Let's take a look at acetylene, for example, which looks like this. So there's only one alternative Lewis structure present in acetylene, but it's pretty likely that this structure is dominantly present in the molecule. So we have this free electron pair on the nitrogen, and this free electron pair can be pulled towards the carbonylic carbon and is forming a double bond, while the double bond of the CO group is alternating, and one electron pair is drawn towards the oxygen, because oxygen is, in this case, has a strong negatively inductive effect, and so a double bond between the carbonylic carbon and the nitrogen is formed, and we are left with a positive charge on the NH2 group. So in the end, what happens is that we get an sp3 hybridization on the oxygen, or at least if we consider the Lewis structures, we tend to get an sp3 hybridization, and on the nitrogen, instead of an sp3, we have an sp2. Now I hope that you got something out of this video, and although hybridization is only a theoretical concept, you might get asked that question as well in your exam, so be prepared for it. And as always, thanks for watching. Please subscribe, rate and comment.